Hi, I'm Matt, and in this video we're going to talk about some terminology we use for matrices and some of the most common types of matrices. So first, let's go into some terms and notation. So here we have a matrix. So you'll see that one thing we note is that we have brackets on either side to denote that it's a matrix. Sometimes you might see parentheses used. I typically use the brackets. And then we see that inside of the matrix, we have A11, A12. We call each entry in the matrix an element. So for example, A12 is an element. A11 would also be an element, and so on. We're going to come back a little bit more to what those subscripts mean. The next thing we're going to talk about is a row. So a row is a collection of horizontal elements. So in this case, A11, A12, and anything to the right of these would constitute the first row of the matrix. And we're typically going to describe the number of rows in a matrix by m. Next, let's talk about columns. So for columns, these are going to be a collection of vertical entries in a matrix. So we see we have A11, A21, and then anything below A21 represented by these ... dots. Those together form a column, more specifically the first column of the matrix. We'll denote the number of columns in the matrix by the letter n. So now that we've talked about rows and columns, we could talk a little bit more about the notation we used here. So again, each entry in a matrix will be an element, and then to denote which element it is, we'll typically write them in the form Aij, where I denotes the row and J denotes the column. So in the case of A12, this 1 tells us we're in the first row, and then this 2 means we're in the second column. And again, we'll use that for every entry of a matrix. So now that we've talked about rows and columns, we can now talk about the shape or the dimensions of the matrix. So we already said that in a matrix we use m for the rows and n for the columns. We put these together to get the shape of the matrix, which we write as an m by n matrix. So let's look at an example of this. So we have the matrix here. The first row is 5, 0, 1, and the second row is -8, 3, and 12. As I just implied with saying that, this matrix has 2 rows. And again, that's because we have 2 sets of horizontal entries. Similarly, we see we have 3 sets of vertical entries, so we have 3 columns. Hence, we have 2 rows, so m equals 2, and 3 columns, so n equals 3. Putting those together, we get that this is considered to be a 2 by 3 matrix. So now that we've talked about some terminology, let's look at some special types of matrices. The first special type of matrix we're going to talk about is the zero matrix, and as its name implies, it's a matrix full of only zeros. And more specifically, it's a matrix of any size where every element is 0. There's 2 notations we'll use for this. One is just a bolded 0, as seen here, but then sometimes for clarity, we'll subscript the size of the matrix and write 0 and then a subscript of n by n. So for example, O 2 by 2 is a 2 by 2 matrix, so 2 rows and 2 columns, where all of the entries are 0, as we see here. Another type of matrix we should talk about is the square matrix. So a square matrix is a matrix with an equal number of rows and columns. So in other words, going back to our earlier notation, n, so our number of columns, is equal to m, our number of rows. So an example of this would be the matrix given here. We see that we have 1, 2, 3 columns, and we see that we have 1, 2, 3 rows. So again, since we have an equal number of rows and columns, this is a square matrix. Now that we've talked about square matrices, we could bring up one more piece of terminology to discuss, and that's the diagonal. So the diagonal is a collection of elements where I equals j, or said differently, the row number is equal to the column number. So for example, the diagonal will include the A11 since it's first row, first column, A22 since it's second row, second column, and so on. One more thing with the term diagonal, Diagonal is only well defined for a square matrix. If n does not equal m, so we have a different number of rows and columns, we're not really going to talk about the diagonal. Now, with that being said, there's a special type of matrix called a diagonal matrix. And a diagonal matrix is a special type of square matrix where the terms not along the diagonal are zero. So written in the math notation, this means aij is equal to 0 if I does not equal j. So again, that's just a fancy way of saying if we're not along the diagonal, it's 0. And we can have a 0 along the diagonal as well, so there can be a 0 element on the diagonal, but that is not necessary for it to be a diagonal matrix. So this would be an example of a diagonal matrix, and we see that because along the diagonal, we have numbers, which that's fine, but then anywhere not along this diagonal I just drew, all other numbers are 0. Now, let's talk about the identity matrix. So the identity matrix is now a special type of diagonal matrix, where the terms not along the diagonal are 0, but now the terms along the diagonal are 1. So now, written in the mathematical terms, we have aij, so any part of our matrix, will be 1 if I equals j, so 1 if we're along the diagonal, or 0 if I does not equal j, or if we're not along the diagonal. And we're going to denote or write the identity matrix as a capital I, would typically bolded, or a capital I with a subscript n, just where n represents the dimension of the matrix. So for example, I2 would be our two-dimensional identity matrix. We see 2 because there's 2 rows and 2 columns. And then this is the identity matrix because along the diagonal we just have our 1s. And then not along the diagonal, so not on that line I just drew, we have 0s. The last types of matrices we're going to talk about are triangle matrices or triangular matrices. So first we have an upper triangular matrix, and this is one where all the elements below the diagonal are 0. So here would be an example of this. We see along our diagonal, our elements are non-zero, and then above it, we also have non-zero elements. And again, since all of our non-zero values are in the upper part of the matrix, we call this an upper triangular matrix. Opposite to this is a lower triangular matrix, and this is one where all the elements above the diagonal are 0. So for an example of this, it will be this matrix. I'm going to draw our diagonal, and then we'll see that everything below it is a value that's not 0, and everything above it has a value that is 0. So again, since all of our non-zero numbers are below or on the diagonal, we call this a lower triangular matrix. That's all I have for today. Thank you so much for watching. Leave any questions you have in the comments below, and have a great day.